So if you haven't watched the first video of getting the Raspberry Pi set up with the kit that I purchased and the SD card, go back and watch that first video. In this video, we're going to be walking through getting this set up and ready to go to run Rosetta at home. Now you can run whatever project you want that is supported on the ARM64 architecture. In this case, we'll be installing Ubuntu on the Raspberry Pi. In this particular case, I'm not going to be using the 128 gigabyte SD card that I talked about in the first video, because that one already has Ubuntu installed on it and has Rosetta at home configured and everything ready to go, and was just before I started recording this video running on Rosetta at home. So this one I'd like to keep and not have to re-image it again and set everything up. So this is my good copy of everything running in Rosetta at home, just waiting to be resumed. So instead, I'm going to use a 32 gigabyte Samsung Evo Select card. That is one of the ones that I use with the Raspberry Pi Zeros, and that I think will serve as a good test to show that even with any card that you might have laying around, that you can get Rosetta at home to run with a slower card, a smaller card. There's not really an issue there. So I removed the SD card out of the, well, this one wasn't actually plugged in, but all right, so we got our SD card reader here, plug in our SD card, and go get this thing flashed with Ubuntu Server 20.04. We're going to head over to the computer and take it away from there. We've got our SD card plugged in, and first thing we're going to do is I'm going to show you two different ways to configure this, probably 2/3. Depending on what operating system you're on, you got a couple different options at your disposal. And first thing you can do is just go to ubuntu.com and go click on download, go find Raspberry Pi, install Ubuntu Server on a Raspberry Pi 2, 3, or 4. And you could follow their Ubuntu tutorial, but that wouldn't be any fun because I'm making a video about it. Ubuntu 20.04 LTS is the recommended build. I would say absolutely use that one over 18.04. 18.04 was the first version that they provided support on the Raspberry Pi 4. But they do indicate that official support begins with Ubuntu 20.04 LTS. We'll download the 64-bit version of that. I already have it downloaded. If you are running Rosetta at home, you need 64-bit. Don't even need to look any further. And after it's downloaded, you can go look at their tutorial, and I'll show a couple things that are interesting. Prepare the SD card. They actually show, did they just update this? I think they just updated this. Because the thing I was going to say is, yeah, you could use the Raspberry Pi imager. I don't think this was even here yesterday. Yeah, they were showing before. Did it just update it 17 minutes ago? Before, they had options here for, oh, no, I don't want the imager. I already have it. They had options here for using a series of commands in terminal for macOS to just do a direct disk image, which I might show in a future video, because it's kind of cool and I use it for backups and things like that. But they're just showing use the Raspberry Pi imager for everything, which is not a bad solution. So I'll just show two options. There is a third option for those that run Linux and Mac OS, where you can use DD to image anything. So let's go do that. So I've already got it downloaded, and I will get it launched. There it is there. Here's the Raspberry Pi imager, pretty straightforward. We'll pick our operating system, and here we're going to go to Ubuntu, and then it will give you the options for Ubuntu 20.04 LTS. Make sure you select the 64-bit, then choose your SD card. Make doubly sure that you're not overwriting some other media. On to verifying. All right, verified. We are good to go. You can now remove the SD card from the reader. So we'll say continue. So you'll see now that the SD card has been ejected, but we want to actually remount that disk because we want to make some configuration changes prior to its first boot. So I'm just going to unplug it and plug it back in again, and it will mount back on the desktop, and we should see the system boot partition appear on the desktop. I'll come in here, open this up, right-click on config.txt and open that with your favorite text editor. In this case, I'll be using Atom. We'll come into the config.txt file, and the one thing I want to do is configure it so we have overclocking enabled out of the box. You're going to see another system boot volume appear. That's actually the already configured and running SD card that I've been using for quite a while. And I'm opening that one up to remember what I had it configured to. This is it. Overvoltage equals 3, ARM frequency set to 1900 megahertz or 1.9 gigahertz, and the GPU core frequency increased from 500 megahertz to 550. So I'm going to lazily copy this over to the other card. I will leave this text in the comments. So if you just want to copy and paste it and you're kind of concerned about making sure you get everything typed in right, no worries, just go ahead and copy and paste it from the description in the video. Make sure you save it, and then we're done. And we'll eject this and then just put it in the SD card reader on your Raspberry Pi and prepare it for its first boot. All right, so now that you got the SD card all set to go, put it back in the SD card reader, and now you'll need all your connecty bits to get this thing fired up for the first time. First, power supply. Second, the mini HDMI to HDMI adapter to plug in to an external monitor, a keyboard and a mouse, and an Ethernet cable. So let's go power it up. You may have seen when it was first booting up that it did do some stuff and then showed the Ubuntu login and then continued doing things. And you'll get to this point where it is created the SSH host keys and does initialization, and it looks like it's still busy doing something. What you can do here is just press the return key and it should give you the login again. And so now we're going to log in with Ubuntu as the username and Ubuntu as the password. And immediately you need to change your password. Cool. And once it's done, it'll log you in and it should show you that you have updates to apply. There we go. 26 updates can be installed immediately. 4 of these are security updates. To see what those updates are, you can run app list upgradable. All we're going to do here is sudo app update. And sudo app upgrade. And you might see these cache lock things happening, which means it's still busy processing other things, which it's not super clear. So we're just going to Control C on that and escape out of that process and let it finish doing whatever it's doing in the background. In fact, we're going to go look at top real quick and see what's going on. It appears like there's unattended upgrade already occurring. You can see it here. Looks like it's busy doing extract temporary files. It looks like it's installing updates already. This is a little bit of a wonky part of the configuration because it looks like it's done, but it's actually not. I just let it hang out for a while. It looks like it's finished now. So we'll go back and we'll run our sudo app update just as a formality. It doesn't need to actually update repositories again, but why not? And then sudo app upgrade. We'll see if we still have, there we go. Now it's showing that it has the ability to write and make modifications. So apply all the updates so that you're current with Ubuntu server. This shouldn't take too long. Now we're back to the prompt. I think it's a good practice before the next step just to give it a reboot. So we're just going to go ahead and sudo reboot. All right, we've rebooted and now we're looking at the login, and this time we need to use our fancy new password. And after this, the next step is choosing a desktop manager. Now I've tried all the desktop managers that are directly supported by Ubuntu server, which includes Xubuntu, Lubuntu, and Kubuntu. And I've found all of them, while they're great desktops, they do not seem to work well with BOINC, if not BOINC plus Rosetta at home. So the desktop manager I'm going to be installing is actually Ubuntu. And just as a side note, you don't necessarily even need a desktop manager in order to run Rosetta at home or BOINC. So let's go ahead and get the desktop manager installed. So we're just going to do sudo app install Ubuntu desktop. Whoop, if I can type it, that'd be super awesome. There we go. This is going to take a while. There's a lot of stuff that it's going to install. We're gonna let this go, and through the magic of time lapse, come back once it is finished. The desktop is finished installing, so we're just gonna do a sudo reboot now. And then we'll come in to the desktop environment once it reboots. There we go. We're now at the Ubuntu desktop. I'm gonna log in with the password that we created before and log in. A few things are needed to configure the system to perform best when running Rosetta at home or any compute-oriented project. And so two things we're gonna do here. One is set up a swap file, and two, set up ZRAM to enable memory compression. You can see that when you first set up Ubuntu, especially Ubuntu server, it's by default not going to enable swap. So if you go into all and select the system monitor, then you can see in resources, there's no swap that's been configured. What we'll do is we'll come over here. We're just gonna create ourselves a swap. So the first thing we'll need to do is allocate swap space. So we're gonna do sudo f allocate, and we're just allocating ourselves a file, -L, and the length of it is going to be, I'm choosing 10 gigabytes because there's 4 gigs of RAM, and I'm going 2.5 times that as a general rule of thumb for the amount of swap space you want relative to the amount of physical memory that there is on the machine. And I'm just gonna call this swap. And the next thing we're gonna do is actually change the permissions of that, just using chmod to 600, and then we're applying that to our swap. The next thing we're gonna do is to take this and make it into a swap file. So we're actually telling the operating system, hey, this thing that I just created, it's now swap. So there we go. You can see now it's saying setting up swap space version 1, tells me that's 10 gigabytes. It also gives you a UUID. And finally, we're gonna want to add this using whatever text editor you want. I'm using Nano, into etc fs tab to make it permanent. I had to look this up because I had forgotten what it was. But we're just giving it the path, which is swap, and that it is swap and swap. So we're just typing swap a lot of times. Defaults 00. And that's all that's really needed here. And then we'll exit. And then we're just gonna check to make sure the swap is actually turned on. Swap. I meant swap. Swap on. Show. It's not, because I need to restart. So we'll take care of that in a second. So you'll need to restart once all this is done, but don't do it just yet because we're gonna do ZRAM at the same time and then do a restart. For ZRAM, it's pretty easy. All we gotta do is sudo apt install ZRAM config. Boom. Goes and grabs it, configures it, and then it's done. We're gonna cat on the swaps, but we're not gonna see anything just yet again because I'm gonna show you that nothing is ready. Yeah, see, nothing's ready. So I'm going to restart the system. Rebooted. Fresh reboot, everything good to go. Let's test out to see if all of our swaps and ZRAM are all ready to go. System monitor should show us the swap is set up. There it is, swap is now enabled and has 11.9 gigabytes. And that's because, from my understanding, it's in combination with ZSwap, and we can check ZSwap by just going into terminal and catting into the processor swaps. And there we have it. Actually, it shows all of them. There's our /swap, and then there are the ZRAM memory compressions at 485 megabytes, and it's one for each CPU core. So there's 4 of them for the 4-core system. All that's left now is just to get BOINC Manager installed and get Rosetta at home running. So sudo apt install BOINC will get us the BOINC Manager. It's 29 megabytes. Let that go. So now we have BOINC installed. Let's go launch the BOINC Manager. This illustrates the reason why I chose the desktop manager instead of just doing this from command line, because as soon as you launch BOINC, you can see all the projects that are available, and you can walk through and look at various things and see what the project does. You can go to their website. You can kind of shop through what things you might want to donate compute time. Some of these will not work on the Raspberry Pi or for ARM architecture. More are adopting it by the day. So let's select Rosetta at Home. Click Next. It's going to connect to the project. If you've not used Rosetta at Home before, then you say you're a new user and create your account. I am, so I will just go ahead and log myself in. And it's going to communicate with the project, attach itself, and then it's finished. This is the default simple view for BOINC Manager. I prefer the advanced view. You can just see more things and kind of understand what's going on with your system. So right now it's going to be downloading a bunch of things. The first thing that BOINC is going to download once it attaches is this application right here, which is the Rosetta application. So BOINC manages all these projects, and it monitors and allows certain executables to run, and those executables work on the work units that come in for a particular project. So in this case, Rosetta 4.20 is the application, and down here you can see there are 2 tasks waiting to run, as well as a database and some flags. So once it's finished downloading all of this, it will run benchmarks to see what the fixed point and floating point speed is for the CPU, and then it will start running. So the final thing is look at the computing preferences, which should have downloaded from my web preferences. It did. Excellent. This is how I have it configured on all of the Raspberry Pis. I let it use 100% of the CPUs and 100% of the CPU time, because these things are dedicated to just doing compute. I only have it store 0.5 days of work and then store up to 1 additional day of work. Request tasks to checkpoint at most. I increased this from 60, I think, as a default, to 1200 to minimize impact on the disk I/O. It's not a critical thing, but if it's at a very low value, it might slow things down. Network, I just let it do whatever it needs. Disk, for using the 128 gigabyte card, these are the settings that I would configure. Use no more than 50 gigabytes, leave at least 30 gigabytes free on the system, and use no more than 50% of a total disk space. If you're using a smaller card, you may need to adjust these as needed to allow the project to run. It might give me an error here because this is for 128 gigabyte cards that are in the other systems. And I'll show that to you so that you know if you've allocated too much space, so the project will actually tell you and protect your machine from just allocating all of your disk space. Finally, when computer is in use, I just have it use all the RAM, 98%. Finally, page swap file in use, I let it use 75% of the swap file. It never seems to go that high, but I give it free reign of the swap file since it's the only application that's running. So I just save that. And I do have a notice, which I believe is going to tell me that there's a problem with the amount of space that I've got on this disk, because it's only running 1 task. There we go. Notice from server, it needs more space because I have told it to use a lot more space. So let's go and fix that in disk and memory. So leave at least 30 gigabytes free. This will need to be unchecked because there's less than 30 gigabytes free because it's only a 32 gigabyte card. Saving that, and then we'll update it because I have to show you it running 4 tasks at a time. There we go. It's giving a bunch more tasks.
And I'll appear here once it is good to go.
So we're running 4 tasks. There they are, all running. And just to show that this is actually running at 1.9 gigahertz, this application will just give information on what the CPU is doing and at what frequency it's running at. The default governor that the Raspberry firmware uses, and I believe since Ubuntu is just running on top of that, selects 2 different frequencies to run at, 600 megahertz, and then whatever you set it to. After it installs, just run cpu freak-info, and you will get a listing that shows what each core is doing. For each CPU, CPU 0 is running 31% of the time at 600 megahertz and 68.74% of the time at 1.9 gigahertz. You might look at that and go, well, it's only running 2/3 of its time at the frequency you selected. That's because I've only recently started BOINC Manager. So if I were to rerun this, you'll notice that the percentage of time that it is spending at the higher frequency keeps increasing. And if I were to let this run for, say, probably 10 minutes it'll probably be up into the high 90s. The ones that have been running for weeks, those are at 99.9 something %. And the only percentages that are at the 600 megahertz is when tasks finish and a core is idle waiting for the next task to start. So that is all for this video. If you like what you saw, give it a thumbs up, like and subscribe, and I will see you in the next one. Take care.
You're washed up. You got nothing.